Hello everyone. It's November the 7th. Alright. Oh, got another easy one today. Alright. Let's try to do 2 today. Alright, so this is make the string great. Given S, lowercase English letter. Well, strings these days. A good string is which does not have 2 adjacent characters where for I in this, SI is a lowercase letter and SI plus 1 is the same letter but in uppercase, or vice versa. So a good string does not have that. To make the string good, you can choose 2 adjacent characters, then make the string bad, and then remove them. You can keep doing this until the string becomes good. Return the string after making it good. The answer is guaranteed to be unique. An empty string is also good. So in this case, so I can remove this, right? In this case, I can remove this, and then remove this, and then remove this. Okay, so what do you think? Well, what we can do is 100. I mean, we can always brute force it. I'm just thinking about if there any easier method. A stack, right? You push, you push, you push. Ooh, you pop, you push. Yeah, this is a stack. Gotcha. See what they're trying to do. It is a stack. All right, let's get a stack going. All right. Yes. 8. Okay, so we have a stack, right? And then for letter S, if stack and stack this one dot to lower is equal to letter dot to lower. I think I'm actually not sure. No, I think it's just lower. No 2, just say lower. Then stack dot pop. Right? Otherwise, else stack dot append letter. Okay, so just keep doing this. When you find it, you pop it, and then you keep adding, and then at the end, we're gonna return this dot join stack. Let's try. This is gonna be LeetCode. This is gonna be empty string. And this is gonna be itself. I got distracted. I got these notifications. Oh, what the hell? Notifications that telling me that there are danger. Flash flood. Okay, why doesn't work? I remove these and then E. Oh shoot, my bad, I forgot. And stack -1 is not equal to letter, and yeah, it has to fulfill all 3 to make it work. 1544. Use stack. Alright. Alright, on this, okay, moving after this one. Removing stars from a string. You're given a string which contains stars. In one operation, you can choose a star in S, remove the closest non-star character to its left, as well as remove the star itself. Return the string after all stars being removed. So I can choose a star. Wait, does it matter which one I choose though? I choose a star and I remove, choose a star and I remove LeCode. Always be unique. Yeah, it is always be unique because each has to be corresponding to one. Alright, so what do you think? What I think is a stack again. I mean, hold on. This problem, I ran them on this problem yesterday. And it's quite surprising that both use stack. You just use stack. You get a star. You get something out. And get another star. You get something out. Keep pushing. Yeah, this is just stack. And honestly, this is not like any more difficult than the one we did today. For the challenge, to me they're the same because this is the same method unless I'm missing something, which is likely, but if stack and letter is equal to star, then stack.pop, else stack.append letter. Wait, hold on, what if it's now I'll make it say this is this, right? Now we say if stack, because but it says operation is always possible. Yeah, so operation is always possible. So I believe in it. Like, what's the difference between this one and the problem we did today? Right? I don't see any difference. Well, I see. The difference is this one you have to do it using stack because it's like 10 to the 5th. The easier one we did today, you don't have to. You can't just you can even brute force because it's so small, so it doesn't really matter. But this one it does. This one it does. It is pure luck, right? Life happens in weird ways. 2390. Use stack. Okay, so in this case, let's try another one. How many have we done? Let's do another one. Number of substrings containing all 3 characters. Given an S consisting of only characters A, B, and C, return the number of substrings containing at least one occurrence of all 3 characters. Substring. ABC, ABCA, ABCAB, ABCABC, BCA, BCAB, BCABC, CAB, CABC, ABC again. Only A, B, and C. Okay. So we want to know the total number. Okay, so we want to know the total number. So we're given a string, right? We want to know total number of substring. Let's see if DP works for this case. So I can say, if I know the total number of substrings ending in a certain character and in a certain position, right? All the substrings and ending here that contains all ABC, I know the number. Now I'm looking for everything ending in the next one. Okay? If everything ending in the next one, so anything ending in the previous one, right? It works. Like the previous one, if we have ABC ending in the previous one, then it shall be, so each position we shall have that everything ending in A, that will not work, but everything ending in AB, everything ending in AC, and everything ending in BC, and everything, not ending, everything contains. Oh, contains. You're talking about contains only AB, contains only AC, contains only BC, and then contains only ABC. So if I have all these four values, now give the next value, right? So we give the next value, it's definitely the previous contain ABC. I add my current one, it also works. And the previous, if I am a B, then the previous AB gets extended. Previous AC now become ABC. Previous BC also extended. So can we do that? Well, we find the first three. So in the first example, we have ABC, that's the first three. So we have, if we going to be AB, AC, and BC, right? So we call it, we call it 0, 0, 0, 1, right? And now next letter is A. So AB contains only AB, right? Contains only AB. Oh, contains only AB. No, that should never contain only AB. It's always going to be. Huh. No, ending in C. My God. All the substrings, right? So things ending in the third one is C, BC, and ABC. So we have, well, contain only C. We have to have all of them. We have to have A, B, C, A, B, A, C, B, C, and A, B, C. All of them. So in this case, ending in C contains A as 0. Okay, so this is our reference. Okay, this is our reference. So it will be 0, contain only B is 0. Contain AB, ending in C, contain AB as 0. Contain AC, only AC, that's also 0. But contain BC, we have 1. Actually, contain C is also 1. So A, B, C, contain C is also 1. AB, AC, AC is 0. BC is 1. ABC is 1. So that's the first thing we have. We may be able to use a, let's say, a very binary value to rep. No, we're gonna adding. So no, it's gonna be an array. Okay, now is A. So we say we're ending in A. Previous is 0. Now ending in A is 1. Here is B ending now contain only B. Yeah, that's just gonna continue to be 0. Contain only C. Ending in A contain only C. That's nothing. You have nothing that's ending here contains only C. So that's gonna be 0. Next one's AB, contain only AB. So we look at the previous one, contain AB is 0, and now it's A, so that's still 0. Contain AC. Oh, previous contain AC is 0, and now I have 1. contain BC, only contain BC, not even A as 0. Contain ABC, and previous is 1. And for me, right, I contain AC, I just look at previous is only contain C. Oh, if AC is previous only contain C, or only contain AC, right? And then if it contains C, and then we add contain AC. Contain A, contain B, C, that's all 0. So contain AB should be the previous AB. Now the previous AB is going to be 0, right? The previous AB is 0. So now it's also 0. And then the previous ending B is also 0. That's also 0. So AB is 0, right? Now AC, previous contains C is 1. And I'm A, right? So I have 1. And previous contain AC is 0. So that's just 1. BC, right? BC contain only BC, but I'm A. So yeah, that's not going to work. So that will be 0. The last one is ABC. So for ABC is previous ABC is 1. So we have 1. And previous BC, right? Previous contain only BC. That's 1. So that's 2. That is 2. So we have 2 here, right? Yeah, I think we can do this. Oh, but it's gonna be 1, 2, 3, 4, 5, 6, 7. 7 times 5 times 10 to the 4th. Let's try this idea. It's fun. It's a fun problem. One, 3, 5, 8. All right, what do we have? Okay, so we're gonna have a DP table, which is just going to be, we need to analyze the first. How do we analyze? How do we get a first one? Well, we find the last one, right? Right, we find the last one, the third one, and then we say, whatever that is, we put that one in, okay? And then we find these two. Yeah, it's just going to be the last one, these two, we have it, and then all these two, then we will have it. And then these two, if they're the same, then maybe it'll be easier to use a dictionary. I'm gonna use a dictionary. It's just way easier. A, right, B, C. This is a base. D. Not D. AB. AC. BC. Of course, ABC. Right? So that's the base. And then DP equal to base. How'd you copy that? Well, I think we can do this to copy. Actually, I'm not sure. I might just be kidding myself. How'd you copy a... Wait. Copy a dictionary. I know there are many ways. I just forgot. How do you copy? Oh, you can call .copy? Shallow will be fine. I don't need a deep copy. Shallow will be fine. Yeah, shallow will be fine. I don't really care. Shallow will be fine because it says just to dot copy. Yeah, shallow will be fine because it's all value. So I can say, and I can print base and then print dp, and the value will be different. Base and dp, base and dp. Yeah, it'll be different. So it's fine. Shallow is okay. Okay, so we copy. And then we're gonna say for I in range 2 minus 1 minus 1, right? I'm not sure, is that the way to go? So, and then these two combined, we can put it. I'm gonna say if they're not the same, right? And then we have yet another one. Yet another one. And then what? You know what? Nah, I don't think this. So what we say is dps2 plus equal 1. That's for sure. And then we say if s1 to 2. No, 1 to 3. Because it's 0, 1, 2. If you want a 1, 2, it happens to be 1 to 3. If 0, 1, 3 is in base, in dp, then dp s1 to 3 plus equal 1. So that's just one of these, right? Else, that must mean they're equal, because there's only possibility, right? It must be equal. Oh, shoot. Nah. No, no, no. We say if S1 is equal to S2, right? So that's the same. Then dp S2 plus equal 1 again. Else, then we say dp sorted. Oh, sorted. Are you kidding me? How do I? Oh my god. Key equals. S1 plus S2 if, my god, S1 is smaller than S2, else S2 plus S1, alright? And then base key plus equal 1. Alright, how about the other one? We can say if man, it's hard for me to express. So I can say if the first three are different, that's ABC, right? And then if they, that's actually not true either. So we have the last one, right? We have the last one, we have the previous one, and then, man, we have to keep going down this path, right? If this is equal, then we do this. Then we consider the first one. Then we say if S0 is equal to S1, then all three are the equal. Then dp S2 plus equal 1. Else, now they're not equal to the other two, so we can do k. So it will be very similar to this, okay? but it's not. It's gonna be S0 plus S2 if S0 is smaller, or else S2 plus S0, right? Then we say base K plus equal 1. So that's that. Else we do this, then we say if S0 is equal to S1, right? Because ending, so we handle these two, then we handle, so this can equal to this, right? Or this can equal to this. Because now we know is 1 and 2 are not the same. Right? These two are not the same. So if this is equal to one of them, right? We say if S0 is equal to S1, then base K plus equal 1, because it's the same. So we have 2, right? It's like AAB, right? In an AAB situation. Right, Elif. So now we say 0 and 1 are not the same. Okay? 0 and 1 are not the same. So we have like AB, 0 and 1 are not the same. But it might be the same to S2. So we have a BAB situation, right? If it's a BAB situation, then that's also the same. Yeah, because only in B and in AB, and that's in AB, right? And they're not the same. So either equal to A or equal to B, that contains only AB, right? Contains only, these three also contains only AB. So as long as if it's equal to 1 or is 0 is equal to 2, doesn't matter, we do this. Else, that means it's not equal to 1, not equal to 2, and 1 and 2 are not the same. So that's when we say ABC plus equal 1. All right, so that's the base case. Dear Lord, that's the base case. Now we're gonna start, let's say for I in range 0, 1, 2, 3 to land S, okay? Okay, so the current letter is SI. Now what we're gonna find is, first of all, temp equals base.copy, right? Say temp SI plus equal 1. No question about it. Actually, we might want to go one by one. Yeah, we want to go one by one. Hold on, let me think. So we go ABC first, right? And then we find this, and then we say if it's equal to SI, then it's gonna be this plus the previous one, right? If it's not equal to, so yeah, if it's not equal to, then it's gonna be nothing. So what we need to do is this shall plus equal to 1 plus dp si. All right? Whatever is ending here is all the same, and then we're gonna end here. So that's that. Now we're gonna do doubles. Okay? Now we're gonna do doubles. How do we do doubles? Look at my current one, and then I want to find the other one, right? So if I am an A, yeah, we can just say, right? If SI is A, then I need, because I'm A, so I need to find the previous one. Of the previous one, we need to find B, all right? So B alone, or AB, so that can add to, or C alone, or AC, that can add to, right? So like if I'm A, then I'll look in the previous one as B or AB, so this can all add to my AB. If a previous one is C or AC, that can add to AC. If previous one is BC or ABC, that adds to my ABC, right? So how can I express this in an easier way? It just seems to me this whole thing is just convoluted. I wonder if I can code it in such a way that make it easier to express. So what I can do, I just don't know. I mean, this maybe it'll be easier, like even with this analysis, maybe it'll be easier to just brute force it. Like, if you want to analyze it, like if it's A, right, it will be easy to handle, right? If it's easy to handle, if it's A, then we just, this will add previous ones B and AB, and then this will add previous ones C and AC. Yeah, honestly, I think it will be actually easier to do it that way because only 3 situations, right? You know what? I might want to do it this way. I can say if SI is equal to A, right? If SI is equal to A, then temp A, actually we can just equal to, right? Temp A can just equal to, then in that case, I only need a counter, right? Temp A will equal to dp A plus that's it, dp A plus 1, right? And then temp AB equals dp B plus dp AB. Temp AC equals dp C plus dp AC, and temp ABC equals dp AB, no AC, no BC, come on man, plus dp ABC. That's it. That's that. And you know what? I am going to do this one as well. So there's no base. Okay, I'm going to use counter. I'll make it fun. Yeah, that's going to be a counter. Then we say if S2 is equal to A, right? Then dp A equal to 1, dp dp A is equal to 1, dp AB, right? ABAC. You know what? This is actually, hold on, because I don't have the previous. Unless I actually do, because the first one is going to be by itself. The second one, yeah, it might actually work. You know what? Screw all this. Seriously, screw all this. And we just say for letter in S, temp is going to be a counter. Okay, so if letter is A, then temp A was equal to this plus 1, AB equal to this, AC equal to this. Yeah, it doesn't matter. So if the first letter is A, then temp is just going to A be 1, everything else is going to be 0, right? Everything else is 0. And then we can copy this, right? We say elif, if it's B, then temp B equals B, and then AB will equal to A and AB, and then this is going to be BC is equal to C and BC, and ABC is going to be AC and ABC, and else. letter is equal to C. Right? So this is C equal to this, and this is gonna be, let's say it's called BC. It's gonna be this and BC. This AC is gonna be A and AC, and ABC is gonna be AB and ABC. Right? So once we're done, we say dp equals temp. Then we move on to the next one. All right, move on to the next one, and I will just update. And then we're gonna return the last one, so dp abc. Let's see. This one we can actually find and produce very easily. We can produce test case. It's not hard at all. Yeah, that's edge case is 1. Yes. Number of substring. Oh, the first one is not right. Okay, that's okay. I think it should be added together. Yep, it should be added together. So we need to have a res, right? And then dp, yes, and then we say res plus equal to dp abc, and then we're gonna return res. There we go. I have high confidence in this one. This one is going to be very interesting. All right, let's run some tests. Let's make it bigger. Random import choice. Okay, and then from random import, just a choice. Then we say for this in range 10, let's do 10 test cases, and then we're just gonna say s equal to dot join for this in range. How long do you want to do? Let's do 100. Okay, and this is gonna be choice what? A, B, C. And now I'm gonna print. Okay. Yes. Like that. Fun time. Go. Oh, and there's some edge cases I want to try as well. Try one more edge case. Then we're good to go. There we go. All right. Ooh, it's so slow. What the hell? Is it because of counter? Okay, I mean, it's always possible to do like this. 0 times 7. Okay, so the order is going to be A, B, C, A, B, A, C, B, C, A, B, C. How about this? Okay, so this is going to be 0 times 7. Maybe we can AB requires previous now. So A is gonna be 0. Okay, so all A is gonna be 0. Oh shoot. Okay, all A is gonna be 0. Then all B is gonna be 1. Okay, B is going to be 1. Or C is going to be 2. Okay, or AB. What's AB? 3. AB is going to be 3. AC is going to be 4. BC is going to be 5. ABC is going to be 6. Yep, they'll still work. Of course it still works. We're just trying to see if it's going to make it faster. A lot faster, but still not the fastest as we can make. I don't know. I mean, this is the best I can get. Let's see the solution, see how the people do it. Okay, so use DP. Each position in S records the number of strings that and at position I we record the number of strings that and in SI and contains only A, B, C, AB, AC, ABC, and ABC. Then when we get to SI plus 1, we can use the DP value of, we can use DPI, right? We can use DPI equals the number of, to compute DPI plus 1. To speed things up, we use an array to represent a 1D, and each element of DP, and yeah, and times O7N, and we have this runtime. All right, let's see. Is there any smarter solution? Yep, look at this. We only need 3. Sliding window. Count C for C and ABC. Okay, I just everything is 0. This plus equal 1. Huh? Count SI. So I want to find ABC. So I extend until we find the first ABC. Okay, we can find the first ABC, and then once we find the first ABC, then anything that extends, they all have ABC. Oh yeah, Yeah. Everything that extends will have, they all have ABC. So we find the first thing, so we start from the first, with the first position that contains all ABC, right? And then we know everything behind, they all have ABC. Then we shrink one, and then we keep search the second. Then everything that all have ABC. Then shrink this, and everything that all have ABC. I think that's what it means. Yes. Count our values. It's slightly different. So we just find the first one, right? And then if that's it, then we find one, okay? And then we keep going, right? We keep going. If it's not, then wait, hold on. We have this, right? And once we find, we move this forward, and then we find one, and then we add another one, then we find one, we add another one. That's just the previous one. We just keep adding until we find another one. Then I move forward again, and when I move forward, that means from the start to this position there are two, right? There are two independent, there are two base. And then if I keep extending, if it doesn't happen, then all these two base can form. I think that's what it means. What's this one? Position of the last occurrence. Find the last occurrence. Okay. So we find the last occurrence of A, last occurrence of B, and the last occurrence of C, right? And then the minimum of the last occurrence. Because every time we'll, and then if last occurrence, right? So AB, if no C, C will be -1. So if we go to last occurrence, that will be 0. But once we have a C, right, then we go last occurrence among all three, right? Among all three. Then we say rest plus that value. Because we have the last occurrence, we have this, right? We have the three things. They form the base. So everything in front, they all count, right? Everything in front, they all count. So it's going to be 1 plus the last occurrence. So that's all, right? That's all ending in the current position. We have found all of them. And then we keep going, right? We keep moving forward. Okay, we keep moving forward. And hold on. Yeah, so we find the first. So this is similar to sliding window, right? But we use the last occurred. So we will always find the last, the minimum, right? The minimum substring. The minimum substring ending in the current position that barely forms ABC, right? And then when we have that, then everything in front can all be included, right? So basically that's it. We want to find the smallest, like for each position, you want to find the smallest. But if it doesn't exist, that's okay. We just go find the first one, right? From the left to right, find the first one that you have the smallest ABC that can form, and everything in front of it can form as well. And then that's it. That's everything ending in that position. And if you want to keep moving down, right? If you keep moving down, then ending in this position will be. But are we not counting all of them? Oh, that's why for every time you do, like every time if you update, because we look for the last occurrence, right? So the last occurrence, if you keep moving up, you repeat, and that's a new thing, right? And if we have the last occurrence, then that's a new thing. So yes, I'm gonna use this one. Sliding window is good as well. All right, this is much better than my solution. Much better. Okay. Both are based on sliding window. First is more explicit. The key idea is to find the minimum range, to find the minimum range of left and right such that S left to right barely contains all A, B, and C. Right, once we find that, all the substrings, right? All the substrings starting from 0 to 0 to start and ending at end all have ABC, all contains ABC, all have A, B, C in it. The explicit method uses sliding window to locate left and right. Expanding it or shrinking it, it doesn't really matter, right? Now you find the first one and you get everything, and then you try to expand. Not really. What does it do? It's just we keep adding, right? We keep adding, so because the J keep moving, you keep adding, and then once it hits, then we just remove, right? You have to remove one, and then we don't have anymore, so that's just one, and then you keep adding one, then if it's good you just keep removing one, and then you have two, right? To locate, right, to locate the first left and right such that S left to right plus 1 contains ABC. Then once S left and right contains ABC, and move left forward, right? Until S left to right plus 1 does not contain ABC. Then the current position of left represents the number of substrings, right? Number of substrings from 0 to left, right? From 0 to left, that substrings from the beginning, right? From the beginning to right that have all ABCs, right? Yeah. Then those are the all. Then we keep expanding, right? Then we keep expanding on right, and then repeat this process. We keep expand, and every time we'd expand, right? Every time we'd expand, we have to, yeah. You know what? I'm gonna write both. Hold on. It's hard to explain. It's hard to explain. Alright, so we should say first sliding window solution from Lee. Once we find Si is j plus 1 that contains ABC, we do I plus equal 1, right? Then there are I number of substrings from the start, and in J that contain all ABC. Then we expand on J. Each expansion, right, for each expansion that does not create a new Si plus I to j plus 1 that contains ABC, right? We have to add the same I because we have that many, right, substrings. So yeah, so every time we have to add, then we have then now if we find a new, right, then I increase on the I, so I grows because we have a new thing, right? We have a new thing. Oh yeah, this is hard to reason. I find this one hard to reason. Yeah, so you find the smallest, right? And then if you keep moving forward, you find the next smallest. You find the next one. So each time you find the one. Now the two methods is the same. Each time you find one, you have to add the previous. Let's just do the second one. The two are the same. We find the first substring. Find the first Si to j plus 1 that contains ABC. Okay. Then before we find the next substring that contains all ABC, each time J expands, we have to add I number of substring to the result. Right? As each time J expands, because we find this, right? And we say, I love them, they all contain, right? So we have I love them. And each time we expand, it's just this one, and then this, right? this and this, this and this, plus and everything in the front. So it's that much adding this one, right? And we have this, it has to be this one. Yes, now I get it. So each time j expands, we have to add I number of substring to the result. Because I have to contain this one until we find a new one, right? Until we find the next is m to n plus 1 that contains ABC. Right, so we find that. Then what? Yeah, then what? Yeah, then what? We find the next one. Then everything up until these. But they are also considered in the previous one. But we don't count the previous one anymore. Because once we have this, yeah, we have the root. This is the root. This is the new root. And for each root, everything up into the root. Right? So we say ending here, ending in here, and ending in here. How many? Yeah. So we find things. We repeat the same process. Okay, then we say last. The last occurred index of A, B, C. Yeah, let's do -1. Okay, rest is 0. I letter A and numerate S. Then last letter equals I. Right? And then rest plus equal to 1 plus minimum last. Actually, it's ORed. -97. This is a sliding window. Yeah. Very smart method. Genius. Fast. Space. Okay, that'll be it for today. I'll see you guys tomorrow. Adios.